Bismillahirrahmanirrahim. Assalamualaikum and good morning, everyone. How are you today?
Fine.
Salam.
Salam.
Good morning.
Okay, before I will continue our lesson today, I have these two things. And what you think these two things? Anyone can answer? Yes, Arif.
I think that that there is two strings that is connecting to each other with a tube.
Yes,
Right.
that's correct. All right. Yes, Sadia, what do you think?
I think it's like a hydraulic system.
Yes, that's true. Okay, so what you think if I give a pressure at the small piston string, and what will happen to the big piston string? Anyone can answer this? Yes, Najia?
What I see, the water in the small string moving into the big string.
Yes.
So because of that, the piston of big string lift up. Maybe because of the pressure.
Let's we see together, okay? If I push this ring, and what happened? Okay. 1, 2, 3. They're going up. That's right. This is because when I give a small force here at small string, it will produce a big force at the end of the big string. Okay, you get it? So that's we'll learn
Yes.
today. But before we continue our lesson, I will call Hazmi. Can you read these classroom rules?
Okay. Classroom rules. First, student needs to wear proper attire, and then student need to mute mic and open the camera, and then student need to raise your hand if you want to speak, and last one, student have to respect each other.
All right. Thank you, Hazmi. And I hope my beloved student also can follow all these classroom rules. Okay. All right. We proceed.
Okay.
So from my sharing earlier, I will explain about topic of Pascal principle. Okay. Learning outcomes, first of all, is student will be able to define Pascal principle correctly. And next, student will be able to explain the principle of pressure transmission in an enclosed fluid based on the situation. All right. Anyone remember how to calculate pressure from our past class?
Yes, I remember.
Yes, what it is, Saidia?
P P equal to F divided by A.
Yes, that's true. Pressure is equal to the force per unit area. P is pressure, F is force, and A is area. We will use this formula again later. Okay. First of all, the definition of Pascal principle. Pascal principle state that the pressure is applied on an enclosed fluid is transmitted uniformly in all direction in the fluid. Okay. So this is pressure transmission in a enclosed fluid. This is a hydraulic system, simple hydraulic system. Okay, first of all, pressure force F1 will apply on our input piston, and then pressure will produce on a liquid surface A1. Pressure will transmit uniformly to the output piston, and then same pressure produced on the liquid surface A2. Lastly, force will produce on output piston, and the force is greater than force F1. Okay, are you understand?
Yes, understand.
Yes,
All right,
understand.
thank you. So if you don't remember, I have made a simple flow chart that you can screenshot and use it for revision next time. Have you done screenshot, class?
Yes, sir.
Yes.
Okay. Next, we will continue on how to derive the formula. Piston 1 and piston 2. the pressure, as we know, the pressure is equal to the force per unit area. But in Pascal principle, state that pressure on the output piston is the pressure transmit from the input piston. P1 is equal to P2, means that the pressure is the same. Okay, then we can derive this formula. F1 over F2, F1 over A1 and equals to F2 over A2. Got it?
Yes.
Yes, sir.
Okay. I will give you some example. Okay. Given the area input and output piston is 5 cm squared and 2 cm, 25 cm squared, find the force output piston when the force at output piston is 10 Newton. So the information given, we just put in our calculation, which is F1 is 10 Newton and A1 is 5 cm squared, and X, because we don't know what we need to find, because we need to find it, and the area of A2 is 25 cm, and then just use the simple calculation, simple math, and we got it 50 Newton. Everyone understand for my example?
Understand,
Yes.
sir?
Yes,
I
sir.
understand.
Yes, all right.
Yes, sir.
If anyone understand, we will go to the activity part. Okay, everyone, I will give you guys 1 minute for you guys answer the question that I given for each name, and then after you answer, I will ask the answer. Okay, I will give you 1 minute.
Okay, sir.
Okay, are you ready? Screenshot this question.
Yes,
All
sir.
right.
Yeah.
Yes.
Okay. So I will give you 1 minute from now. Hashamira, I heard you having quarantine today. So how are you?
I'm feeling well today. Much better.
Much better. Okay. Hazmi and Arif, have you eat today?
Thank you, sir, for your concern.
All right. Welcome, Shamira. Not yet.
Not yet, sir.
Oh, okay. Okay. You have half of the minute more to answer the question. Sadia, what you doing today? This morning?
Mm, morning. I wash my clothes. That's
Oh,
all.
that's all. Okay, that's good. That's good. Right. Few more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Everyone done with the calculation?
Yes,
Yes, sir.
sir.
Yes. Okay. Okay. First one. Sadia, can you read and give your answer?
Give the area A and B is 10 centimeters square and 50 centimeters square. Find force at output piston where force at input piston is 12 Newton. So my answer is 60 Newton.
Are you sure with your answer?
Yes, I'm pretty sure.
All right. So let me see. So yes, that's correct. The answer is 16 Newton. And your calculation is same as me?
Yes, sir.
All right, that's good. Okay, next we will proceed to Najia. Give the you can give your answer, and you can read and give your answer.
So my question is, given the area A and B is 20 cm and 100 cm, find force input piston when force at output piston is 50 Newton. So my answer for the force input is 10 Newton.
Are you sure?
I'm very sure.
All right. So the answer is 10 Newton. That's good. All right. Before we continue, I will to remind all of you. Don't forget the unit, okay? The unit for Newton, for force, and for area. This is because physics are really important with the unit. Okay. All right. Next, we proceed with Hazmi. Can you read?
The input force for the hydraulic jack is 60 Newton, which has a cross-sectional area 0.8 centimeter square. And what is the cross-sectional area of the output cylinder that will produce a braking force of 840 Newton? So my answer is 11.2 centimeter square.
Okay. We will see the answer. But before that, have you seen the hydraulic jack?
Yes, normally I see it at workshop.
Yes, that's correct. This is the hydraulic jack, and we will see that hydraulic jack. And your answer is 11.2 cm, right? Yes.
Yes.
Okay, that's good. Okay, next we will proceed to Arif.
The output force for the hydraulic brake is 760 Newton, which has a cross-sectional area of 50 centimeters squared. What is the cross-sectional area of the input cylinder that will have force of 70 Newton? So my answer is 1.4 centimeters squared.
All right, 1.4 centimeters squared. So the answer is correct. And Arif, do you have a experience having a bicycle with the hydraulic brakes?
Yes, sir.
Yes. Okay, that's good, right?
Yes, that's
Yes.
good.
Okay, next we will go to the last person, which is Samira. Can you read and give your answer?
Yes, sir. In a hydraulic system, an input force of 4 Newton acts on a piston with surface area 0.5 cm squared. Calculate the output force produced on a piston with surface area 6.4 cm squared. And my answer is 51 Newton.
51 Newton. All right, that's true. Have you
Yes,
seen this hydraulic system anywhere?
yes. I have seen at Carbonet.
Oh, yes, that's right. Okay. So with the end of Samira, can someone concludes our lesson today? Yes, Arif, can you give your conclusion?
So to conclude today's lesson, in Pascal principle states that the pressure applied on an enclosed fluid is transmitted in all directions in the fluid. So pressure at input fluid and output fluid will be the same.
All right, that's correct. But I want to put some words that make the sentence complete, which is Pascal principle state that the pressure applied on enclosed fluid is transmitted uniformly. You need to remember uniformly in all direction in the fluid. Okay, so it will apply the Pascal principle. Pascal principle. Okay. Right. Before that, when the pressure is same, what is the difference for force and area? Hazmi, have you have the answer?
I think when the area is increased
Mm-hmm.
and the force will increase.
Yes, that's true. That's we learn today. Okay. So in physics, pressure is equal to the force by unit area. But in reality, pressure is equal to the world by your criteria. So to become a better person, you need to become a better you. All right. Thank you for listening our class today, and we will see you in the next class. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Bye.
All right.